here we have an initial value problem. It's a differential equation, and it will end up being exact, and I'll show you how to find that. So the problem is 2y e to the 2xy minus 5 over y. That's all to the dx. And then that's plus the quantity 2x e to the 2xy plus 5x over y squared, and that's all dy. And that whole problem equals 0. We do have y with the x value of 1 equals 1. So in a minute we'll plug in our x's and our y's to figure out what our constant value is. So here we start with our m, which is this whole section, and that m is where we differentiate with respect to y. So we're just trying to find out if this is an exact problem. So we have 2y e to the 2xy minus 5 over y, and we want to differentiate with respect to y here. So as we differentiate 2y, that's going to be 2, because we're going to go differentiate, leave, and then we're going to leave this plus, leaving this one, and differentiating for that one. So just the product rule. So 2e to the 2xy, and now I left that alone, so I'm going to add that to, now I leave the first one alone, and I'm going to differentiate the second part. So using the chain rule up here, remember I'm in respect to y right now, so that y, there's a little 1 above it, that 1's going to come down, multiplied by the 2, just give me a 2, and 2x is going to come out front, and then again I have e to the 2xy. If you forget how to do that, you can review that, but that's not what this problem's all about. So I got that side, the left side, my m. Now I'm going to do my n, which is the right side, and it's kind of the opposite. It says dy, so I'm going to differentiate with respect to x here. So I've got 2x e to the 2xy plus 5x over y squared. And if I this should be equal. If they're not, then this isn't, we would have to use a different strategy to solve this problem. So with respect to x, I've got 2 again, like I did over here, but for y. And then again, I leave the second part alone, 2xy, just chain, or not chain rule, but where we add them together, product rule. And then we're going to add those to 2x. I'm just leaving that one alone. Now I'm changing this one. Again, same thing with over here where we had a little 1 above the y, we have a little 1 above the x. Comes down, multiplies by the 2, that's 2. The x removes because that goes to 0, and then we have a 2y left. And again, we still have the 2e to the 2xy. And then we add that. Again, we're with respect to x here, so the y squared on the bottom is going to stay the same. Y squared at the bottom, and then the 5x, that 1 comes down, it's just a 5, and then the x goes away, so it's a 1. I'll just leave that 5 on top. So I'm going to leave that 5 on top, and oh, over here I forgot to do this, which sometimes screws me up. I'll just add to the front part over here. But if I'm differentiating this in respect to y, and that y has a -1 above it, so that -1 is going to come down and make that 5 positive. So I've got 5, and then that -1, remember when we differentiate, that gets smaller. So that -1 goes to -2. -2 is actually smaller, but I'm going to put that 5 over a y squared, which is really just that y to the -2, just like you have here. I just want them to look kind of the same. So that looks the same, this looks the same, and this looks the same. And so now those are equal, and we can say that that's exact. Now I didn't rewrite it just so I don't have to rewrite it, but you can kind of see where those match up. Okay, then after that, now that I know that it's exact, I can use our exact method. So the first thing you do in your exact method is you're going to take the integral of the left side. So just this dx quantity. So I'm going to take I'm going to integrate that with respect to x. Okay. So I've got 2y e to the 2xy minus 5 over y. So I'm going to have to differentiate this. I'm going to differentiate this side, and then I'm going to differentiate this side. So I could put a dx on both sides and subtract them, but I'm just going to leave it alone. You can kind of see where I'm going. So if I differentiate with respect to x, that 2y doesn't matter anymore. It's just a constant. So it's just gonna fall down. And then I'm integrating this with respect to x here. So I need to do, well, actually, take that back. We're gonna do a u substitution. It'll be easier. So if I u substitute e, I essentially want this piece, 2xy, to be my u. So u to the 2xy. And then that means that if remember I'm integrating with respect to x, so that this I'm differentiating to make a du. That's gonna drop out. The x is gonna drop out. That 1 comes down and multiplies by the 2, which is just 1 again, or just 2 again. So 2y dy. And if you notice, this 2y dy is also here. It's a dx. 2y dx right here. So that's going to drop out and just become the du. And then my e to the 2xy, remember that was e to the u, and the integration of e to the u is just e to the u, right? So then I have that on this side. And if you remember, my u was a 2xy. So really, that's all I have left is my 2xy. I have a constant in there, but I'm not going to worry about that yet. So now I'm going to do this side, which is, if you remember, that's just y to the -1. But I'm differentiating I'm integrating with respect to x. So that doesn't matter. It's just a constant. It's going to drop out because it's not being multiplied by any x's, so it goes away. So really, I'm just left with that plus a constant. And we're going to call this constant g of x. Okay, so now I've integrated with respect to x. Now I have to differentiate this with respect to y. Okay, so when I differentiate this with respect to y, I'm going to get here, just product rule again. So e to the 2xy, and now I'm going to do the inside with respect to y, and I'm going to drop that down. That 1 comes there. It's going to be 2x. And then when we take just a function and we differentiate it, it just becomes g prime. Okay, now I've integrated with respect to x, I differentiated with respect to y, and I'm going to set that equal, since they were exact, remember, I'm going to set that equal to this whole quantity. So 2x e to the 2xy plus 5x over y squared. So those are equal. Now, if you notice, this and this are the same. And if I have the same thing on both sides of the equation, I can just cross them out. So now I have g prime of x equals 5x y to the -2. I'm just rewriting that a little bit differently. I guess it really doesn't matter. But what I'm going to do here is I'm going to integrate both to get this back to a g of x, because I need to be able to I'm trying to look for this g of x because I want to make an equation here. So I gotta find the g of x. So how do you find g prime of x? How do you find g of x of that? You integrate it. So I gotta integrate both sides, and I get g of x equals, and again, over here, so I'm differentiating this. If you don't remember, it's way up here. I'm gonna integrate, sorry, I said differentiate, integrate with respect to y. So this 5x just comes along for the ride because it is a constant, and then that I remember that's getting smaller. Sorry, it's getting larger when I integrate. So that's actually going to become a -1. And remember, we divide by 1 bigger than that number. Divide by -1, which really is just going to be a -5. And then y, and then I get 1 bigger there, which would be a -1. So I have g of x equals -5x, and I can make that y to -1, or I can just put it over y. Okay, plus, and here's my constant, plus c. I have lots of constants in there. I'm just gonna do this constant because if you add a constant with a constant, it's just gonna be a constant. So I can kind of combine them all together. Now, if I remember, I was looking for that g of x, right? Right here. So I need to take this whole thing and plug it up into there to get my equation. So I've got e of 2xy plus, here's my g of x, which is actually this. And it's not a plus, it's a minus. Minus 5x over y. And then I'm looking for my c, so I'm just gonna make it equal c. I just pulled this over on the other side. Now, I have to try to find what that, well, I guess I know what that c is. I'm aware of that c value, but I do know that I have a y value and I have x values. Remember up here, it's an initial value problem. So I can put an e to the 2, x is 1, y is 1, and then 5, again, x is 1, y is 1, and that equals my constant. And I got that, if you don't remember, this is the x value, and this whole thing is the y value with that specific x value, which equals 1. So this is your x, this is your y. So e to the 2 times 1 times 1 is just e to the 2. If you don't remember, e is like 2.71. So it's just a number. So we don't have to write out all the numbers because it really goes on forever. So we're just making a shorthand version of that. And then minus 5 times 1 is 5, divided by 1 is 5, equals c. Okay? Now, not quite done yet, because remember, we had this equals this. And so I want to take this left side, and I want to make that equal to c. This is c. This is the left side. So that's the final thing to do, is just take the left side, e to the 2xy minus 5x over y, and make that equal to e to the 2 minus 5. And there is your answer to that initial value problem that is an exact differential equation.